Good. Welcome. Welcome to another of our Wednesday yachting lunches. A little bit about, and what a beautiful view we have out these windows. Holy cow, how can we get lunch and a view all in one take here? A little bit about future speakers. Some people have made a living out of sailing around and cruising and doing video webcasts. And Christina Pericus from Southern California has done just that. She'll be by to come by. She'll be by to tell us how she's done it on August the 1st. In July 18th, Kim Jones and our own Chris Ray will be here to talk all about their trip to Africa with a zillion pictures to show us how close you can get to an elephant and still come to the luncheon afterwards. We'll be hearing from the Extreme Sailing Catamaran crowd in July 11th. Michael Ellis, the noted naturalist, will be here to talk to us on the 20th of June. On the 27th of June, we'll hear all about how we keep the Golden Gate Bridge so beautiful and upright over all these decades, 80 years old now. And next week, we will hear from Bob Devlin about racing sports cars on Marina Boulevard. That actually happened, but it was 100 years or so ago. And I think that R.C. Keefe was a member. Is that right, R.C.? Can you confirm that? I'm pretty sure he was a member. A little bit about our speaker today. Born in Connecticut, unlike lots of people in the sailing world, he didn't start sailing until he was, wait for it, 20 years old. He started sailing at 20, but he was a pretty fast learner. He began sailing in the BVI. And by age 23, he managed a delivery from the BVI all the way over to Greece. And age 23 also, he started racing quasi-professionally in an adventure where they sailed from basically Ireland to Greenland, simulating Eric the Red's Nordic voyage 1,000 years ago. He tried out for the Whitbread team from Ireland in '85, didn't quite make it, and became a sailmaker at Sobstead. As things went along in '89 and '90, he did get a ride for the Round the World race, still called the Whitbread in those days. For a British defender, they were doing well until the North Atlantic, and he basically lost their rig in the North Atlantic, so that stopped their adventure there. By '96, he was technical director for North. He'd moved now to his third sailmaker and was now beginning to do some incredible work in those of us who followed the 3DI and before that, the 3DL formation process of sails. And I went and rode around in one of the little harnesses over in San Leandro back in those days, and they've advanced their technology in an incredible way under the tutelage of our speaker today. So please welcome the Director of R&D and the Technical Director for all of North Sails, Bill Pearson. Bill. Bill, I look just like Bill. But wait a second, you know what we can do? While we're waiting for Bill, let's introduce the first Commodore in the history of the St. Francis Yacht Club, Teresa Brander. Welcome, Teresa. Teresa. Yes, terrific.
I'd love to claim first Commodore. I think I'm first female Commodore, right?
Yes.
Indeed. So thank you, Ron, and welcome everyone, members and guests here at the St. Francis, and also those of you who are viewing online. We love having an online presence, and we appreciate your interest and attention to our Wednesday yachting luncheon, which we're quite proud of. I'm very much looking forward to today's presentation for a couple of reasons. One is I do know Bill Pearson. He's raced with me. He's been my tactician on my J105. I have North Sails on my boat, and I have personally toured the Minden facility where the large molds that Bill will be talking about today, that's where they're located. So I will, I guess, hand it over to Bill. When he gets here. Anyway, so I'm really looking forward to today's presentation, and I'll hand it back over to Ron. Thank you.
Thank you, Teresa. So given that we actually do have Bill in the building, honest, but in the meantime, why not a testimonial from somebody who's been buying his product for a little while? He has no idea that I'm going to ask him to come stand up here. Yes, please, yes, clean off your nose there for a second, Dave. Dave McEwen. He's got a great 52. How is it to sail with those North Sails? Are you winning lots of races, buddy?
Yep. Hello, everybody.
Dave McEwen didn't know I was going to ask him to speak.
It's just impromptu kind of things here, filling the time, I guess, right?
Yeah, right, exactly.
Well, yeah. So I own a lot of North Sales. My salesman, Pete McCormick from North Sales, here does an amazing job representing the company and the products. And Pete sales with me all the time too, which is fantastic to have him out there to work with me. So,
how many sales do you have, Dave?
I have so many sales. I'm pretty much out of room. He's such a good salesman. I have the boat is full of them, my trailer's full of them, the storage unit's full. I can't really pack any more in there. So I'm going to have to find a secondary market for some of these sales. But anyway, so we've been winning some races and having a good time with the Lucky Duck, and we'll be doing the California Offshore Race Week later this week, starting on Saturday. So excited about that.
Great.
Thank you.
Great. Thanks, Dave, for impromptu comments. So, Bill Pearson, we're ready to hear from you. Tell us all about the R&D activities of the Great North Sail Off. Welcome, Bill Pearson. Thanks, buddy.
Thank you, Ron, and to the club for inviting North Sails here today. Just briefly before we get into the technical weeds, a little bit about the company. North Sails is the original company and the largest part of what we now call North Technology Group. We inside the company, we tend to think of ourselves not specifically as a sail maker, but as a materials and technology company that specializes and whose main business is making sails. And we operate now in a space we call between textiles and composites. So obviously traditional sails were textile based, what we call now paneled sails. And modern sails, particularly 3DI that I'm going to talk about this afternoon, is really a composite product made from fiber and resin, as distinct from a textile, which tends to be a woven product. And, starting in the late 1970s, we were making a lot of our own textiles, not exclusively, but we have looms and we have laminators, and we've always made some of the raw materials that you need to manufacture sail membranes from ourselves. And today we're even producing some of our own composite materials. So we sort of vertically integrated, and we control the components all the way down to the raw material level for a lot of the sails we make. And recently, in the last few years, with the textile part of the business, we now actually manufacture and sell sailcloth to other sail makers as well through sailcloth suppliers. And we do the same thing in our composite business, hence a photograph of the airplane up there called the Solar Impulse. So that's the first airplane to fly around the world solely under solar power. It was last year. In fact, it stopped down in Silicon Valley. And the structure of that plane was built from North Sails materials. And it's a spin-off of the 3DI sailmaking technology I'm going to talk about called thin ply technology. So the plane is an 80-meter wingspan, so a wingspan of a jumbo jet. And the top of that wing is all solar panels. And the whole plane weighed about 2,000 pounds all up. And half of that's the structure and half of that's the batteries and the electric engines. And all that structure was built out of North Sails materials. And we also sell some of those materials to a couple Formula One teams. A lot of the McLaren and Red Bull cars are made out of those same materials. We've been on Red Bull for 7 years maybe, and on McLaren for about 6 years. And so we're quite active in the high-end composite space, kind of quietly selling our materials and technology there. And one of the reasons I bring that up at the start is that there's a lot of mysticism and BS in sailmaking, as some people know. And, I bring that up because it's a validation of the fact that there are some other people doing fairly serious things that use our sailmaking technology to do that. So again, quickly before we get into the technical weeds, just kind of a little bit of review of what's going on at sort of the high end, what we call Grand Prix level of the sport, and how that influences and relates to what we're doing at North Sails. So I'm sure everybody in this room is probably familiar with the 3D renderings that and video that photograph came from of the AC-75 flying monohull for the next America's Cup. And there's a lot of interesting aspects of this, and in fact, it might be more enjoyable to spend an hour talking about this and speculating about how this thing is going to work than listening to what I have to talk about. But anyway, I think when I first saw these renderings were released before the full rule was released, and I remember watching the rendering of the yacht race with these new boats and wondering whether the mainsail was a wing or a sail. And you could kind of see there the way it comes down to the bottom there. It looks like it attaches to the boat like a wing. And as it turns out, it's a hybrid of the two. They're calling it a soft wing, all right? So it's got sail membranes on two surfaces. It's kind of with a batten structure and air in the middle. And so it's going to operate partially like a wing, but it can be raised or lowered. And this was very much part of what Team New Zealand was trying to do, trying to develop a wing that would have some utility outside of rarefied America's Cup yacht racing. So the concept of a double surface sail isn't new. In fact, it's over 100 years old. And when I first heard about this, I wasn't super impressed because any time this has been tried before, we all know aerodynamically a double surface sail is more efficient, but the extra weight of having basically two sails up there has kind of always canceled that out. So I'm like, okay, here we go again. But here's just kind of, you can't even tell that's a wing there. It looks like two 3DI sails. And a close look here on the left, you see there's a double clew there with a sheet going to each clew. And the sail closest to you is the leeward sail, and the sail that's a little bit further back is the windward sail. And, of course, on the right-hand side, you can see two battens, and you can see one leech a little closer in, the leeward leech and the windward leech. So it's two sail surfaces with air in between. And check out the mainsail trimmer, He's controlling two sails there, and the telltales are flying exactly perfectly on full sail. Hire that guy. Here's a mock-up of the Team New Zealand camp. And so we're talking about the Team New Zealand wing here. The masts are going to be one design, but the teams can build and design their own wing. And obviously this is public knowledge now, or else I wouldn't be able to talk about it. But here's a mock-up in a workshop of what the wing's going to look like. So on the left there, the white bit is a mock-up of a U-shaped mast, and the wood piece coming up the front is just a lever to adjust it, and as they developed the system here, the mast wouldn't look like that. So the white-shaped, U-shaped mast that is flat in the back, and then you've got two battens coming off the mast, and you can see on the right-hand photograph, the mast is rotated, so it's a wing mast like on a multi-hull or with a wing, and then that forces shape into those two battens, and those two battens will be running through two sail membranes. So there'll be two sail membranes, batten and air in between, and the more you rotate that mast, the more shape you force into the batten. So it's kind of, again, it's a hybrid. It's wing-like, but with a little bit more mechanical adjustability than a sail has, and it will have a higher coefficient of lift and a lower coefficient of drag than a regular sail. But the interesting part, the interesting part didn't come until I saw this photograph here. All right, so this is only 5 or 6 weeks old, and it's a prototype of this first soft wing on a small non-foiling trimaran. And you'll immediately notice the top of the mainsail is dramatically depowered, all right? And this is one of the things that there's a couple things that make a wing a rigid wing more efficient than a sail, but this is one of the main components here, is that with a wing, you can completely depower the top of the sail, so it's really producing no lift and hence riding moment, all right? which you can't really do that with a soft sail because, when you blade out the top of a soft sail and there's no longer a pressure differential between the windward and leeward side, the sail flogs, right? And a flogging mainsail is bad. One of the reasons why a wing is so efficient is you can't completely depower it and the sail doesn't flog. So they've developed a system here where you can really rotate the head of the sail off to completely depower it. And you can see at the top of the mast there's a mechanical lever that can be adjusted for a deck to overrotate that sail and completely depower it. So this is very innovative, and goes a long way to sort of convincing you that this is it's possible. All the big boats that completely foil today have been in the last two America's Cup. There's no other big boats that are completely foiling, and those things have all had rigid wings. So, with this new fancy monohull that's going to completely foil, this mainsail, this wing, is going to be an integral part of making that happen. So this is very interesting. This is the same boat, the same tack, with a photograph on the left taken slightly to windward, seen fully depowered, and a photograph taken slightly to leeward, all right? So for all you aerodynamicists and yacht designers in the audience, is that photograph, the right-hand photograph, where you're looking at the back side, the leeward side of the mainsail, is now got an aerofoil shape at the head, right? Is that just all drag? Or are we now generating lift on that side of the sail, and actually the top of the sail having negative righting moment, so to speak? I don't know. But it's super interesting. You imagine you having the high, and a sail drives the boat forward because it's high pressure on one side of the sail and low pressure on the other side. So now you're going to have one sail where that equation's reversed on the top. That's pretty interesting. So the other thing going on out there today, and if you're really unless you're part of the sail boat industry, or I think a yacht club, you kind of barely know. There's so many around the world races going on these days, you barely notice that they're going on. But the Volvo Ocean Race, which is the fully crewed around the world race, and the original one that used to be called the Whipwreck, is currently going on. The boats just left Newport, so they're partway across the North Atlantic, and there's only a few legs left. And from the North Sail's point of view, what's interesting, it's good business for us, but what's also interesting is that these boats now have really strict sail limitations. So a Volvo campaign can only have 7 or 18 sails now for the entire race, including from when the boat's launched to when it sails all the way around the world and comes home. Those sails are all 3DI sails. We have, in the last 2 events, we have every sail on every boat. But when I raced around the world some 30 plus years ago, we had on a sloop, we had 23 to 24 sails on the boat for each leg. Now you have 17 or 19 to go all the way around the world. And the interesting thing is that they can do that now, right? They used to not be able to do that. Even 10 years ago, a 3DL sail, a coat laminate sail, couldn't do the course that the boats are required to do now with so much upwind work and a couple times across the equator. So the sails are durable enough now that they actually reduce the cost of the race, because you only need to buy whatever it is, 17 or 18 sails, where we used to have to buy 50 sails, You'd have to have a full suit of sails to tune the boat up before they were on a world race, and you'd have to have 2 sets to sail around the world, and you used to carry a spare mainsail with you. So the durability of the sails is actually, the sails are not inexpensive, of course, and they cost a little bit more than a regular sail, 3DI sail, but overall it's reducing the cost of doing the race because you need so few less sails. And this kind of trickles down to all of us in the sailing industry if you need to buy less sails overall. The downwind sails are now also 3DI sails, so there's no more Spinnakers on the boat. There's no more nylon on a boat. They're all composite sails. They're really hard to break, thankfully, because you don't have that many of them. and again, the downwind sails. And I love this picture because you've got all the, the boats are co-ed this time, so you get all the men and women stacked up on the back of the boat there, right? And it's quite a collection of people in weight. And if you look at that group of people and compare it to the part of the boat you can see as a living area, that doesn't look like a great ratio, does it? It's not. It's miserable these days. The guys get paid well to do it, and it's miserable. You can't stand up down there. You've got 9 or 10 sails that are soaking wet the whole time. The boats are soaking wet the whole time, so you're crawling around on wet sails for 9 months down below. Absolutely terrible, and you need to get paid to do that sort of stuff. Dangerous too, So this is more my style here, and as sort of Grand Prix racing has declined over the course of my career, and a lot of you in this room, there used to be a lot of boats in the 40 to 70 foot range that were the hot racing boats of the day, and now everybody races smaller boats, Melges 32s and J70s, or really big boats. And the kind of middle of the sailing market and the sport has shrunk dramatically. So an important part of our business now in our development is on boats like this. And I've sailed with this gentleman for 13 or 14 years, and this is the latest and the coolest or the fastest of the new super yachts, boat called on Frères, 46-meter boat. It's 150 foot plus. And again, the sails you see there weren't possible only a few years ago. It's the first fathead mainsail on a boat that size, first boat with running backstays. If you're a sailor, you can see that the boom is on the center line and sheeted hard on a boat that size. You couldn't do that a couple of years ago. And you look at that headsail, it looks like it's on a Melges 32. There's 11 or 12 tons of load on that clew, and the sail is just shaped like it's a small boat sail. And this is really, I've been in business for a long time, and it's just spectacular, that sails with those size with that sort of load can be as good as aerodynamically as good as small boat sails. And the other important thing to the people that own boats like this, and they're not pinching their pennies, but that, a boat like that used to have a cruising and a delivery sail and a racing sail. And now he only needs that sail, right? So that sail does the deliveries back and forth across the Atlantic. These boats race in the Med in the summer and in the Caribbean during the winter. And he's up cruising with his family in Norway this summer, and he'll use that sail. And all of us that are racing a boat are quite happy to race with that same sail. The sail's not inexpensive. It's many hundreds of thousands of dollars, but he only needs one now and not two, right? And the crew's very happy, too, because taking the sail on and off a 46-meter boat is pretty much an all-day job. So this boat was a 66-meter sloop. This is I think it's still the biggest sloop in the world, single-masted sailboat. Certainly up till 7 or 8 weeks ago, this was on the left there, the 3DI mainsail was the biggest one we'd ever built. It's 1,150 square meters, right? You're talking about a 3,000-pound sail, and it's the lightest thing you could possibly build. The sail loft in Minden is right around 600 square meters. The sail's twice as big as the sail loft. You look at the guys on the foredeck there. Those are not small chaps, right? If one of them, and I've seen a picture, if one of them was standing in that boom, the sail rolls away into that boom. If one of them was standing in that boom, you could barely see the top of his head, all right? I think that was the first sail that cost over $1 million. Maybe you could get better, but you can't spend more money. But this is an important part of the business now, and with the around the world races and the America's Cup, relatively smaller events, a lot of development is done for these sort of boats. So this is only a 40-meter boat, but this is one of the French trimarans sailed by those crazy guys. There you see the skipper walking around, checking out, making sure the foredeck's cleaned up. Skipper's the only guy on that boat, believe it or not. They're racing these boats by themselves across the Atlantic and around the world. It's 42 days and 16 hours around the world now. 3 days and 15 hours across the Atlantic, right? These things are the fastest vessels across the ocean. I didn't say sailboat, the fastest vessel. Nothing else can get across the ocean that fast because the amount of fuel is required to go that fast. It's just a vicious cycle in the wrong direction, right? So the sailboat now is the fastest thing on the ocean over any sort of distance, which is fascinating, and I think it has potential environmental implications one day. This is the Massif is the current latest and greatest and fast one, and you can barely see the skipper there underneath the canopy. He's on that boat by himself. He's got the current transatlantic record, and they're 3D sails, of course, or else the photo wouldn't be there. But the interesting thing is these French guys now. This guy started his around-the-world record-breaking trip with sails that had 45,000 miles on them. He started with sails that had gone around the world twice effectively already, right? And he didn't even think twice about it. I mean, he's young enough that he just maybe didn't realize that racing sails didn't used to go 45,000 miles. And so it's just a testament to the, obviously I'm biased, but the durability of this 3DI product has vastly exceeded what even we thought it would do, to the point where as a company that, makes its living off of replacing sails, we now, for the first time ever, have to actually talk about that because, this guy, 80,000 miles on one suit of sails. It used to be 3 suits of sails to do that, right? And again, this trickles down to everywhere in the sport, and you really, for the first time ever, going back to the original America's Cup in 1851, the highest performing sail is now nearly the most durable sail you can buy. There's exceptions, to some degree, but you can buy a race sail like that that's good for 100,000 miles. For a really high performance sail is really something special and something new. So going back into the technical weeds now. So North Sails has 2 factories 4 hours away up in Minden, Nevada, where we make sails in one piece on these large articulating and reconfigurable molds. So the original idea behind this product was called 3DL, for three-dimensional laminate. Idea was developed by 2 Swiss guys, neither of which had even ever been to university. No engineering degrees back in the day, and they brought this idea to North Sails. It started down here in a prototype facility in San Leandro. San Leandro, we built the first factory you see here in Minden in 1995. Many generations of technology later, but I've met plenty of people in the Bay Area that have been to those original factories. So we started building sails in one piece with continuous fiber running corner to corner, bespoke fiber placement, as we call it, with fabrication robotics, because you couldn't place all that material accurately by hand anyway. And another look at fiber and the shape of the sail being deployed in 3-dimensional space. So if this idea is new to you, the idea is that the mold is adjusted. Just look at a mold from the end. The mold is adjusted into the flying shape the sail is going to assume when it's going to be up and flying on a boat, and then all the materials are built over that shape. So the material economy is fantastic. There's not a lot of waste, and all the structural material of the sail, the fiber, is in the exact place in 3-dimensional space that it needs to be when the sail is going to be flying. So this is a revolution in the early 1990s. The success of this product is largely what the modern North Sails is built upon. There's a look at a very early sail being built in 3 dimensions on a mold in Nevada. Famous guys in the hang glider bag doing the QC. And this is very early sail from 1994 or 1995. They're very kind of simple yarn structure, yarn architecture, but you can see the yarns curving up the sail along the load path lines, as we call them, right? These became known generically in the industry these days as string sails, right? We have the only one that's built in 3 dimensions like that, but a lot of other people produce a two-dimensional version of that, right? But this now is old technology. So again, 25 plus years, and a lot of people talk about cannibalizing their own technology. Not a lot of people do it, but we've done it. We've stopped selling 3DL sails this year. And why exactly would we do that when we stopped selling it when it was still the best string sail on the planet by far? But the reason goes back to those super yachts and those Volvo boats and those big trimarans, and that we have a product now that's so much better and it lasts so much longer. It holds its shape better and it lasts so much longer that we feel like we can't continue to sell something that's vastly inferior and put our logo on it. So we've stopped selling that. And a little bit, we'll break up my pontificating with a little bit of talk about the materials. So, since for performance sailing, laminated sails took over from woven materials, the old Dacron or polyester sails that you're all familiar with, A laminated sail means that the fiber, the structural material of the sail, is glued or laminated to a piece of film. That's a piece of Mylar film. Mylar film was invented in the 1940s for flexible packaging, like that. Potato chip bags, right? Wasn't invented to be used outside, certainly not in structural applications, but when there was nothing else better, this served well to contain the loads in the sail that aren't along the fiber axis, right? The problem with there's a few problems with Mylar. One is the problem that it has memory, and so when you fold a piece of Mylar, it continues to fold in the same place over time, and it kind of work hardens. And your foredeck crews love this because you got your laminate sail and it folds on the same creases all the time. If you're the guy writing the checks, it's not good for you. So it work hardens and it eventually fails on that crease. The other important aspect of this is that this wasn't made to stick things to, all right? It wasn't made to stick fiber to this, and in the material terms, it has what we call low surface energy, right? The atoms, molecules on the surface are very inactive, so it's kind of very slippery and it's hard to bond to that. And so it works good enough, but over time, that adhesive doesn't really want to stick to that, and the fiber doesn't really stick to that long term, and that's what we refer to as delamination, when the adhesive over time as it ages from either UV or hydrolysis, which is moisture degradation, rust, rust for a polymer, so to speak. It tends to come off there. No matter how well you do it, it eventually tends to come off. And it comes off in areas of the world where there's more sun and more humidity. And of course, the other thing about Mylar is, you all know that sound if you've had a Mylar-based sail. But that memory turns into all those little creases, and all those little creases are shrink. And that's why a Mylar sail shrinks. Cuban fiber sails are famous for shrinking a lot, but all sails with Mylar in them shrink because those creases can never come back out. So
Also makes less smooth surface.
It's a smooth surface. Yeah, it has a lot of downsides, but like I say, there's no question. For 40 years, it was good enough. It was the best thing we had. It allowed us to to invent 3DL and develop sails, but we don't need that anymore. And so today, a 3DI sail is just structural fiber and adhesive, and it's nothing else. So in that way, it's like a composite car, a Formula One car, or an airplane wing. There's no extraneous material in there. There's really just the fiber and adhesive. So talk about a little bit about the details of the technology. That's a photograph of Lingy in 2007-ish when 3DI technology, the idea for this technology first developed, was a different two Swiss guys than the two Swiss guys that had invented 3DL. Again, guys that had never been to university, just clever guys. So there's a 3DL sail on the back on the mainsail there, a load path string sail, and an early 3DI sail on the front of the boat. It would be, we bought this technology after that cup, even though that cup was the best year ever for 3DL sails. We built 997 3DL sails for that cup in Minden, Nevada. 997. And that didn't include Spinnakers, so you build that many Spinnakers again, right? Top of the bubble years, never going to be like that again. So we're going to get into the weeds and try to explain why a 3DI sail is so much better and why it lasts so long. And it's a little bit geeky, and I apologize for that. But if there's ever a group of people I could talk to this about, I think they're here. So the history of performance sailmaking is the pursuit of what we call modulus, all right? And in engineering terminology, there's two properties of a material. One's strength. Strength is resistance to break, and in textiles, that's referred to tenacity. Modulus is resistance to stretch or stiffness, and they're completely different material properties. And often a material that has high modulus or high stiffness doesn't have high strength all the time, right? But performance is about resistance to stretch, and not just on sails, on any performance item or tool or toy, a bike frame, a composite golf shaft, the hull of a race boat, of course, a mast. All these things are about resistance to stretch. And in a sailboat, resistance to stretch, the less something stretches, the more it translates the power generated down to the keel of the boat, driving it through the water. And, stretch or give is a shock absorber, okay? It absorbs energy. So like, for instance, a bulletproof vest can often be made out of some of the same materials we use in sails, but they're configured in a way so that it absorbs energy, all right? So in a sail and a mast or boat, you don't want the energy to be absorbed, you want it to be harnessed, all right? So that getting more modulus in the sail or more stretch resistance is the name of the game. And another material property called isotropy or isotropic is a physical property that has the same value and measured in all directions. So I'll explain that. So that's an old shirt of mine. But when you load a material, any material, piece of glass or a piece of steel, when you load it in one direction, part of how much it stretches is how much material moves in to where that load line is, okay? And you can really see this on your shirt, You with your fingers, you pull tension on some shirt, and you can see the fabric move in, right? And that's an important characteristic on how much any material stretches, because if a material doesn't have compressive resistance, it doesn't have maximum modulus or resistance to stretch. And there's an engineering property called Poisson's ratio in all materials, and a structural engineer gets that for any given material. And so resistance to compression in the direction of the load is an important part of materials not stretching. I'm just going to skip that. Okay. I used to talk about, I've talked about in the past about, the history of sailmaking was in the age of material substitution, it was about the sailmaker that came up with the newest material and got it into his sail first, all right? And this goes back to America's Cup in 1851, where all the other challengers besides America had sails that were flax, and America had sails that were cotton, and the cotton stretches a lot less than flax. The sails stayed flatter over the course of the race, and the boat pointed higher. And this was actually noted in the Times paper in London the next day, that the Challenger had a lot flatter sails, and that's because of the substitution of material. And there's a fascinating story about the U.S. Navy and its resistance to cotton until that race that I don't have time to get into. And then the next big material substitution was Dacron, which is a DuPont trade name for a polyester fiber, originally invented in England, but a lot of these are DuPont trade names. Dacron's DuPont trade name for polyester fiber. Mylar's DuPont trade name for polyester film. And Kevlar was the DuPont trade name for an aramid. So there was Dacron, and then we were gluing Dacron to Mylar, and then aramid or Kevlar in the late 70s, 80s, and Spectre Dyneema, ultra-high molecular weight polyethylene in 85, and then carbon fiber we started putting in sails in 1991. My point being now is there's no more new fancy materials to put into sails, right? So this is not going to happen anymore. And it actually takes, to develop a new polymer and make a new material and get it commercialized at a level people can afford to buy it, still takes 15, 16, 17, 18 years, right? It takes a long time. So you have a long horizon on when new materials are coming. And for anyone who's at all technically inclined here, you might have heard of a material called graphene, right? We've been hearing about graphene for 10 years. Ever seen any? Ever tried to buy any? Not yet, all right? So my point here, and my point to the company, is that all sail makers now have the same amount of materials to choose from, so it's all about how you employ the materials. It's all about process, all right? Everybody can buy carbon fiber, and some companies, we use better carbon fiber than them, we use better than aramid than them, we use better adhesives than them. It doesn't really matter, frankly. We all have that same sandbox to play in, and it's the process. It's how you combine those materials now. It's molded sails, fabrication robotics that you need for accuracy and to handle thin materials, bespoke fiber placement, hybrid structures, better use of existing materials. So that's what the factories in Minden are dedicated to, and our engineering staff, we have 2 material engineers in Minden up there that are doing this full time. So now just talk about a little bit in the weeds of why a 3DI sail that is made of just fiber and adhesive is better than a string sail that is made of yarn and mylar. So all fiber or yarn, this is what industrial roll of fiber looks like. This happens to be Dyneema, Spectra, if you will, the European version of Spectra, comes in a factory like this as a quote-unquote yarn. But every yarn is composed of thousands of individual filaments. And up on the screen there, underneath a microscope, you see a Kevlar yarn, and you can see all those individual filaments that are roughly the size of a human hair. And you can see that they're not straight. They're kind of wrapped around that bundle, right? So the interesting in materials science world, the interesting fact here is that one individual filament has what we call better mechanical properties. It has better modulus or resistance to stretch by itself than it does when it's in that bundle, because they're not straight in that bundle, And that's the bundle that's used on a 3DL sail or a woven sail or anything else, The filament's used as a bundle. So if you break that bundle of filaments apart into a tape like that, and you put all the filaments straight, it's 15% better. It's 15% less stretchy by using those filaments as they are and laying them out side by side. So again, all those filaments are then spread out into those flat tapes, and this is basically what 3DI is. And then those filaments are impregnated with resin. It's called pre-impregnation. and they're all unidirectional, all right? And you get 15% better just by using the properties of the material to their absolute maximum, the way it was created. And of course, companies go to great effort to produce something like that, and then we go to great effort to break it apart and use the individual filaments. But again, if you've been in the boating business for a long time, you've heard of pre-preg tapes. Race boats are built out of pre-preg tapes. Masts are built out of pre-preg tapes, and that's effectively a pre-impregnated unidirectional tape with a very soft resin system, so it can be flexible and used in sails. There's a carbon and spectra tape that makes up a lot of our racing sails today. And we manufacture them at 28 inches wide, basically. We slit them down into rolls like that. They go on to this automated tape laying head. Thank you. Someone's looking out for me. And see, there's a look here. So you can see in that photograph, you can see that the white and black threads up there on that roll, and it's going down through the head, and then you could see the flat strips of flat tapes or strips of fiber being laid down onto that bed. Pretty much completely straight, or certainly in comparison to when they're in that yarn format. These are then many, many layers are then built up, and this is where the idea that why I brought up the word isotropic. Okay, so an individual yarn is the opposite of isotropic. It's actually called anisotropic. It has only properties in one direction. That's the whole point of a high-tech yarn. All the molecules are orientated in one direction. So in order to get isotropy, or at least quasi-isotropy, you need to lay down a lot of those fibers in a lot of different axes and in multiple directions, right? So this is what you're doing here. You can put patching in different places of the sail. And here's this is an exploded version of all the individual tape layers that are going into a TP52 jib, all right? So you can see different orientation of the tapes and different colors or different layers. They're all laid down individually and then kind of all stacked together to make this one membrane. So an individual layer of tape, of pre-preg tape, looks like that, with fiber all in one direction. It's gossamer. You couldn't really lay this down by hand. The machine has to do it. And when you have say 15 or 18 layers, you get something like this. You can see how flexible that is. It's not cured. 15 or 18 layers might be in a 35 or 40 foot sail. You get something quite stiff, so it's very, very stretch resistant or high modulus. And then you get up into a super yacht. This is a corner from a crew corner from a 180 foot boat, right? So it's like 1 inch thick there, right? And so they can handle 15, 16 tons of load, right? And so it's made out of this, a lot of layers of that. It's really efficient. You can't bend it by hand. The boat can bend it, but you can't bend that by hand. So it has going back to the two materials characteristics, it's very high modulus, it's very, very stretch resistant, but it's very, very strong when you build something out of a lot of thin layers and compress them together and laminate them. You cannot, with a modern race sail, you never break a sail under straight tension, just under sailing load. If you're just going upwind and the boat's overpowered, and no matter how much wind you have, you can't break a sail anymore. It isn't possible. You can only kind of break a sail by bashing it into things, rigging and runners on sloppy jibes and stuff like that. But very, very strong as well as high modulus. Sorry? Oh, sure. Yeah, you can grab anything up here afterwards. So there's a Volvo 65 mainsail. Again, you're looking at all the stacks and all the different layers that go into those sails, and it's all those layers and all those orientations compressed together that that make the thing so strong and so resistant to damage that you need less sails than you used to. And it's just kind of a little bit of a look at what I'm talking about on the left-hand side. You see all those individual filaments in that rendering. They're all close together. There's not a lot of room for adhesive in there. They're all stacked together. And on the right-hand side, that's kind of like a string sail where you can kind of see the yarns. And, you know, it's a little bit crude, but all the gaps between the yarns need to be filled with adhesive as well, right? Which is inefficient in performance terms. So you can see how the tear strength would be good, really good on that one on the left-hand side, which it is. So although we're not making 3DL sails anymore, so we're not laying those fiber strings on the molds, these 3DI sections come over to the molds. They're laid up on the adjusted mold. Every sail is, in Big Boat World, every sail is completely custom. It's custom geometry, so sizing, custom aerodynamics, custom shape, and custom structure. All right. So this factory is about mass customization. Everything's built to order specifically for that application. That boat sections are stacked up on the adjusted mold there. They're building. You can see there's vacuum ports on the lower edge by the white felt at the end. Vacuum will be drawn to compress it all together. The adhesive's live at this point. Then it's kind of heated up and all fused together, just the way any other composite part is built with just the fiber and the adhesive. And then you pull off this one-piece monolithic with the molded in shape, flexible composite. So recently, in less than a year ago, we started doing something we've rarely done in North Sails. And in North Sails, we always, the famous trickle-down philosophy that we always talk about in sailing or in economics, I guess, as well, you know. We'd always design and conceive of products for the America's Cup and the Around the World race for the high-end stuff and let it trickle down. And we have enormous market share at the high end of the sport, and we don't at or less at the lower end of the sports and more traditional parts of the sport. So we started developing a product very specifically for smaller boats and lower loaded sails instead of for all the guys with tons of money. And we came up with, those are obviously traditional Dacron cruising sails or racing for one design boats, sails cut out of panels of Dacron or polyester yarn. But we started making 3DI sails out of polyester yarn. And so this is counterintuitive because polyester yarn is very durable. You know, it's kind of robust, but it's really, really stretchy compared to all those high-tech materials like carbon fiber and aramid, like really stretchy. And so it's counterintuitive to try to put that into a performance product. And I'll put my hand up, even being the guy in charge of making it happen, I really didn't think it was a fantastic idea. I didn't see how it was going to work. And sometimes you're happy to be proven wrong. So there's some early Dacron sails that are made in that 3DI configuration, fiber and adhesive only, right? They're super durable for the same reason those Around the World race sails are durable, but they're made of traditional, inexpensive, and robust material. There's just a photograph of the 3D molded shape. And, you know, for me, when I look at that, like, I just can't believe a Dacron sail could hold a nice shape like that. Really, I was shocked, you know, because it won't necessarily mean anything to you, but just as an idea, we measure the modulus or stretch resistance of fiber in a number called grams per denier, which doesn't really matter. But carbon fiber is 1,400, so resistance to stretch is 1,400. Polyester is 60. 60, you know. So like aramids, 1,000, Vectran, Technor are 400 or 500. All the high-tech fibers are up there. Polyester is 60. You know, and so I was as shocked as anyone that the result could be that good. And that speaks to what I was talking about, that it's now about the process more than the materials, okay? So we've taken apart the polyester yarn and we've used it at the filament level. So we're using all that 60 that's there. We've got the compressive resistance by having all the multi-axle thing. And you also have a sail that's just going to hold its shape 4 or 5 times longer, 6 times longer than a Dacron sail, right? And it's going to last not as 100% as long as a woven polyester sail, but long enough, you know? It's not going to last for 16 years for a guy who doesn't care what shape the sail is at all, but it's going to last for 7, 8, maybe 10 years, and it's going to have a good shape for most of that time as well, right? This is new, and this is a revolution that the rest of this sailmaking industry doesn't even know is cresting, a wave that's going to crest on them. They don't even realize, you know, this changes everything, and there's very little reason now to really use traditional woven materials. And there's Liz Clark, I know, who spoke here a month ago or so. She was one of our really early test beds. So she's had some, we call them 3DI Nordac for a Dacron polyester sail. And so now you're bringing technology with inexpensive materials to everybody who wants to have performance, even on their traditional boat. And I would say the vast majority of people who go sailing want to have performance at some level, right? So it's now available. And this is just kind of a look at woven materials that maybe I don't need to go over. So I'll just quickly. This is a photograph of underneath a scanning electron microscope at about 500 power of a woven material. So woven materials are 2-axis, instead of multi-axis. So they're not isotropic. They're barely quasi-isotropic. And you can see those are the individual fibers, and you can see all those filaments I was talking about that were breaking apart. You can clearly see them there. That's actually a nylon spinnaker cloth. And so that's very loosely woven when all the fibers are flat, all right? And I'm just showing you that first so you can get your eye around it. And what you have to do, because there's no off-axis control there, is you have to cover all those fibers with a resin, and you can kind of see a white milky surface, and there's all the resin filling in the gaps. That's why a spinnaker cloth is crispy, because racing one anyway, because it's got all that resin on it, right? And the point I'll make about this is, those people that hang their spinnakers up by the clew and fly them off the mast to dry them out after the race, all they're doing is just breaking all that resin down and destroying the sail faster than it needs to be done. So you see someone doing that, $100 bills flying off the back of his sail. This is a very tightly woven, high-quality Dacron. And, you can barely even see what's going on, but going front to back, the fibers you can barely see are the yarns, not filaments, are straight, okay? So it has, it can accept a lot of load in the fill direction or the weft. And then the yarns in the other direction are going all the way over and under. So with a high quality, very robust woven, there's stretch inefficiency built into the material, okay? And that's why, no matter how good it is, that a woven sail stretches. And there's kind of an end-on view. So you can see the yarn with all the filaments, and then the yarns going in the other direction are going all the way over and under. So when you load it in the other direction, you have to straighten those out before the fibers take any load at all, and that's basically sail stretch. Liz Clark did that. The next step on is a product we haven't released yet. It's still in the prototype phase. We're going to combine this polyester material, inexpensive and very durable, with a little bit of aramid or Kevlar, and we're going to make a sail that's mostly polyester, but it can handle a little bit higher loads and go up to a little bit bigger boats. This was one of the very early prototype, only the second or third one that we did for the local Soto 30 Gen 2 that I race on as well. We're kind of we have a soft launch now. We're going to sell 100 or so sails, get a little bit of market feedback, and hopefully this will be released as a product in September or October. and will kind of have a price point above the Dacron and a capability above the Dacron, but it will be better priced than our other 3DI products. And that's it for the main part of the presentation. Do you want me to stop now, or I was going to talk a little bit about Formula One race cars and stuff, but okay, I won't do that. Okay, yep.
Right here. Just sit right
Yeah, I got it. I might need a couple props.
Exactly. I'll ask you about Formula One cars. Welcome again to our Wednesday Yachting Luncheon. Our guest today, live from the St. Francis Yacht Club, our guest today is Bill Pearson, Technical Director of North Sales. Bill, so tell us a little bit about Formula One cars before we get back to sales. You started to mention how much of your total business is non-sales for North at this point?
It's actually, non-sales. I'm going to rough it here. I'll say 75% of the business is sales, maybe 85, but most of the other business is actually marine, a spar making business, and our composite rigging business is now called Future Fibers is a very successful business as well, and the bespoke materials business is relatively small, although very specialized and high margin, and that business is based in Switzerland.
When you say bespoke, what do you mean bespoke?
Bespoke custom, specific for that application. So we talk about bespoke placement of yarn. You're placing the yarn very specifically in the orientation and the density that you want it in.
So I'm going to keep asking Bill questions, but if you have a question, raise your hand, and Charlie will bring a mic over to you. I'll keep asking until I see you queued up for a question. So with the isotropic sales that don't stretch as much, they're lasting longer. And how are you guys making up for the loss of revenue when the product lasts longer?
Good question. We now have private equity owners. The company was started in 1956. We've been mostly privately owned. We now have private equity owners. They're asking the same question. Part of the answer to that is for instance, the Nordac product, where we're producing a product specifically for customers we haven't had in the past, right? At a price point that's kind of below the traditional North Sales price point. So that's part of the answer, but there's still a lot to be figured out there.
Where's the growth in the business these days?
There's not a lot of growth in the business. Sailing's shrinking, all right? And, when I talked in the beginning about the fact that we're now selling some of our materials to other sail makers, so that sort of thing is a response to that. And, as a business in a shrinking industry, you need to have a strategy and a response to that. And the yacht club's no different, obviously. You're a business in the sailing industry. So the business growth for that is for North Sales specifically, because we've always kind of been intentionally at the higher end of the market, is in the smaller boats and the more traditional segments of the market.
What size would smaller be?
Smaller in North Sales terms is sort of below 40 feet. So really in a 22 to 35 size boat range, where I think traditionally it's been perceived that North Sales wasn't really interested in boats that sizes and those type of clients. And I think part of the point I'm making today is that, we've been specifically developing products for those sort of segments of the market and, people that don't have money to throw around as freely as big boat owners.
So a molded Dacron sail like you just showed a little while ago, for let's say a J105, pretty common boat, what would a molded Dacron sail cost for a mainsail, let's say?
You are talking to the wrong guy.
See PD later?
You'll have to see Pete. No, literally,
Sure.
they don't even let me have the price program on my computer.
I got it. All right, Bill. See, we have a question in the corner. Yeah, Paul Kamen.
Hi. Back to the soft wing with the over-twisted masthead. That looks like a means of generating a huge amount of riding moment. So in theory, at least, the boat never gets overpowered, no matter how hard the wind blows. There's another way of doing that, of course, and that's with the windward hydrofoil pulling down when the leeward hydrofoil pushes up. I understand that the last round of America's Cup boats had rules restrictions that prevented that windward hydrofoil from pulling down. As far as you know, are we going to have similar restrictions like that this time around? Will they apply to the foils or to the rig as well? And which system of producing riding moment do you think is going to prove to be more practical and more efficient?
Right. I'll preference this by admitting I'm not an expert on the America's Cup rule at this point. However, the foils are going to be one design, right? And this is
that's terrible.
It's interesting, It's interesting for a lot of reasons, and one is normally a guy designs a boat first, and then he designs the foils, and now you're going to be given the foils, and you got to figure out what boat to go with it, right? But that's the prerogative of the guy who currently holds the America's Cup. But anyway, this is a monohull boat with no keel. There's going to be two foils, one on either side of the boat, and the windward foil is going to be fully lifted out of the water, and it's going to be providing riding moment to the boat because there is no keel.
So it looks like we're only left with aerodynamics.
Well, you have one foil in the water, and then so to answer your question, a lot of the riding moment is going to come from the fact that this huge ballasted foil is completely out of the water now, and then there'll be one underneath the water.
So the foot-pounds of the ballast foil.
Ballast foil is riding moment, and of course, to the other part of your question, and I'm not an aerodynamicist myself, but what I was pointing out in the early part of the talk is it looks like you're going to get riding moment from the leeward side of the top of the mainsail as well. It's all going to be challenging because part of the rules this time around is all that stuff has to be adjusted by people, not by computers. So it's going to be very, very
But it looks like at the top end of the wind range, the over-twist of the top of the wing is going to be the whole game.
Right. Yeah, and that's a big deal. And that is the single key element that might, in theory, make the soft foil act close enough to the way a rigid foil acts to allow these boats to fly all the time, right? If that doesn't work, then the whole concept's in big trouble.
So give us a week in the life of the director of R&D for North. What do you, if you were to break down what you do in a week, how much time are you spending on materials? How much time are you spending on, shape? How much time are you spending on, what are the categories if you were to define your weekly activities?
Yeah, I guess we break up the technical jobs inside a sailmaking company inside of North Sails, maybe in a way that isn't obvious. So, since you mentioned shape, I'll start with what a sail designer does. Okay, so we talk about a job description in the company as a sail designer. We've got about 86 of those around the world. I don't think anyone else probably doesn't have 5. So a sail designer's job is the shape or the aerodynamics, right? And I rightfully have no input into that unless I'm trimming. But the sail designer's job is not the structures. So there's a group of people that are engineers that do the sail structures, which is the yarn layouts, right? So there's a specialized group of sail designers that do that, kind of math guys, right? They tend to also write the software. And then aerodynamics are married with structures. Kind of all that happens outside of the factories in Minden, Nevada. So effectively what I'm in charge of is materials development and new technologies and things like that. And So I've had a kind of a front row seat at the table for both 3DL and 3DI, so the two most significant technologies in the sailmaking industry in our. Sorry.
Great. A question from the back of the room. Lance.
I have three totally unrelated questions.
Okay.
The first one just popped up because I'd never seen the tape before. I see that the tape doesn't actually hold air. It's not really windproof by itself. So what's the minimum number of layers of laminate that you need in order to have a sail that actually holds air and you don't get leak through?
You know, like all the interviewers on NPR say all the time, or all the guests, good question. Yeah, the absolute bare minimum is 3. And even then, the sail's a little bit porous. So really, I say 3 because we've got some sails on the Swiss lakes on a D35 multi-hulls that are very, very specialized, with only 3 layers in some places. But the real limit is 4. So you need at least 4 to have porosity, full porosity.
Okay.
So no porosity. Sorry.
And second, for the economics. For the factory in Minden, does the technique for construction, is it faster or slower to make these bespoke sails compared with doing it with traditional panel construction? And does it take more people, or how much of that is automated?
You know, I don't, it's a little bit hard to answer with for sure, for a very big paneled sail, the factories, as you saw from the photographs, the factories in Minden are automated. Okay, so all the fiber placement and stuff is automated. So that's vastly more efficient for a bigger sail. You know, we don't really compare it to paneled sail making anymore, because you wouldn't even consider really building a sail like that out of panels anymore. You know, it's just inefficient, and the sail just wouldn't be good enough on a boat that size. You know, overall, it's more efficient because it's machine hours instead of labor, I guess. You know, so there's a lot of capital investment, as you could see. You know, but it's been amortized over 25 years now, so it's much more efficient. You know, I know it doesn't seem that way to people that purchase sails, but the effective price of the sail hasn't really changed that much in 20 years or so. You know, when I was making paneled sails for Admiral's Cup boats in the late 80s and 90s, you know, the sails cost a similar amount to what they cost today if you factor in inflation, and that's because there's a lot of pressure with sailmakers who haven't invested as much money in technology, and that kind of keeps the price down. And like in other endeavors, the automation and efficiency and stuff like that helps keep the cost down as well.
And third, because so much of the strength comes from the layering of the laminate, if for some reason there is something at sea and you have some sort of major rip, what do you have to do that's different for repair of these sails if, say, you're in the middle of a crossing and you have a long way to go before you get to port?
You, like a composite, you glue them back together now. I don't think the guys even, you know, back in the day I was a sailmaker on and around the world boat. We had a big sewing machine down below, and I spent a lot of time on it. And they don't even have sewing machines anymore. You glue them back together. And, you know, you don't necessarily do this on a boat, but in the sail off you do it sometimes. You treat it like a composite part. You know, you cut it out, you sand or grind a scarf around it, and you glue a piece back in, because it is a composite, you know.
Yes, a question in the front. Ms. Danielson, yes, go ahead.
Okay. I have a question. We're here on the Marina Green. The Marina Green was designed for people to lay out their canvas sails so they could fold them. You mentioned that people are still down below with wet sails. So my question to you is, And you also talked about the Mylar sail and the memory of the Mylar sail causing problems, so people started trying to roll them. How are you storing these sails? How do I get them down below and store them? Or I'm just simply putting them up and racing around the world and never bothering to take them down? You could tell I was a crew, not a skipper.
Some people do that. Those big multi-hull guys, they just leave them up and they roll them, you know. No, I mean, all sails have to, all racing sails have to come down and go into the bags and be stuffed down below, you know. And the ideal situation is one design sailors, you probably know they roll their sails, all right? And that's the best way to do it because you don't put creases in them. But it's just a fact of life that you have to fold your sails up and put them down below. But it is true for any modern sail that the sail's happiest in getting the least damage when it's up and flying, and a lot of the damage in a modern sail comes to when you're stuffing it down below because you've got carbon fiber and materials that are brittle and mylar and stuff like that. And even when we have to ship them out of the factory, you know, you're micro level, you're damaging the sails a little bit possibly. So, you know, a sail's least damage, believe it or not, when you're using it, even if you're using it in a lot of wind. And it's just a fact of life. And they last well enough, I guess is the answer, you know. And because of not having a Mylar, the new composite sails, the 3DI sails, are less prone to damage because the elongation of the adhesive, that, you know, that's a composite, but it's flexible. The elongation of the adhesive in there is 1,400%. So the adhesive is very, very flexible, and that in itself allows those fibers that are fairly brittle to be bent without cracking.
How would you ship one of those giant sails on a 150-foot mast? Are you shipping them rolled, or how do you do
They get made. They get a custom shipping crate made in Minden. You know, it's part of the job of the maintenance guys is to build shipping crates, and that. The 66-meter sail I showed you, it took 25 people to fold that sail up at 6 o'clock in the morning.
Was that flaked or rolled?
It's flaked and then it's rolled. Goes into the shipping crate, and then it will go, and a sail like that these days goes to the boat yard where the boat's being built. It's unflaked and unrolled from the shipping container, and then before the boom goes onto the boat, the sail's rolled into the boom, and then the whole thing is craned on the boat. And so as a sailmaker, you want to be sure it's 100% right the first time. Because is it expensive to take it down and change something?
Kim Dessenberg.
I have a question about the resin and another question about the durability. Is it epoxy resin that's used, and is it catalyzed resin, and does it have UV protection?
Yes. It is not epoxy resin. It is catalyzed. It is not epoxy resin. So in our thin ply technology business, when we're selling these type of materials to Formula One and to aerospace, that business uses epoxy resin. It uses the same technologies, the same fiber placement heads, but that business uses epoxy resin for rigid composites. These are what's known as high molecular weight polyester resins. They're catalyzed. They cure very, very slowly, and that speaks to the elongation I was talking about, which is like 1,400%. You know, so they're very, very, very soft. Well, they are catalyzed. They are live.
How long? You said long cure time. How long a cure time?
The full cure time is about 7 days.
For what size sail?
Any size sail.
Any one of the 3DI sails.
So what, you know, when you're talking to your salesman like Pete, you know, sometimes there's a minimum amount of time you can. It's 21 days actually is a minimum amount of time we'll design and produce a sail in, and once the sail comes off the mold, it's set and the shape is set into it, but the adhesive system isn't fully cured for about 7 days, and so it comes off the mold and it sits in. It has a post-cure period before we start working on it. Right? So
you make the sail on the 3D mold,
Yep.
Then you take it off that mold and make another sail in that mold. And how do you keep the shape when it's curing? Is it already firm enough?
It's set, yeah.
It's already set enough?
It's like 85% set, so the shape is set into it, but you don't want to fold it up and put it in a box.
So you put it someplace flat and it just holds its
They
shape?
lay flat before the guys crunch them and stick them through sewing machines and put the rings and the corners on them before you put them in a box.
Mm-hmm.
And does that resin have UV protection inherent?
Yeah, in certain types of sails that, for instance, going to be sold for cruising applications, we put UV inhibitors in the resin. And we also the material that makes sails white is TiO2, titanium dioxide, which is one of the components in sunscreen. Right? Yeah. So yes.
And then currently with string sails, you have a certain number of tacks and the sail gets worn out.
Right.
Does a 3DI sail have that same life expectancy, only longer, or how do you rate that?
Well, a sail eventually gets worn out. A modern sail through fatigue, right? Much more, as I was talking about during the talk, when a sail's highly loaded and in tension, that's what it was designed to do, and you're not really wearing a sail out, particularly these days with a 3DI sail. Even if you're using it above its wind range, you're not really doing significant damage to the sail. But taking the sail up and down, stuffing it in the bag, stuffing it down below, and tacking it around a rig is where you do wear a sail out. But a 3DI sail just lasts dramatically longer and can take dramatically more abuse, largely because it's not being stuck to that film, right? That film doesn't like to bash into the rig at all, right? Or to be folded.
So what wears out a sail? What causes a sail to wear out? And what do you define as wear out? Losing its shape?
Sure. Well, you might want to say there's two different definitions. For a racing sailor, it's when the sail loses its optimum shape, right? And at levels of the sport, you have vastly different tolerances for when that is. Back in for instance, the Valencia America's Cup, so the last big America's Cup, the guys use the sails for 25 hours, right? So there's no client outside of the America's Cup level that would find that acceptable, right? The around the world sails have to go for thousands of hours. So there's shape longevity, which is vastly enhanced with the 3DI composite sail, as well as overall durability. And then there's kind of like ultimate lifespan before the sail is going to break or fall apart. And I can say that 3DI is still new enough, being 7 or 8 years old, that the ultimate lifespan seems to be really at least that long. Whereas with a string sail, we used to warranty a sail for about 3 years, even though it could probably last about 5. But when its ultimate life was kind of roughly as long as its racing life, whereas with a 3DI sail, I don't really know what the ultimate life is yet. It's a long time.
Gotcha.
In performance sail terms.
Another question, Ellen Coleman.
I have a curiosity about the way you store the new sails for the America's Cup. I understand the old ones, they have to get a crane and lift the wing off for the mainsail. Mm-hmm. How are you going to put the boat to bed at night with these new sails? Yeah, so very specifically, the concept of that soft wing that Team New Zealand came up with was so that that soft wing can be raised and lowered like a regular sail. So it does not have to be taken off the boat. And, that also means that there's applications beyond just the America's Cup. You have to buy a mast specifically to use that wing sail, but it could be retrofitted to any boat. And for sure, once the concept's proven, people will start building boats with that type of sail, and because they'll be, relatively easy to use and very efficient. Yeah, so that's part of the concept, not having a crane off a wing.
So we have a question from Facebook. Julia.
Yeah, we do. Norm Vidette Jr. asks if the windlets on the foils are one design or not.
The wind?
Winglets.
The winglets.
With the proviso that I'm not an expert on the rule, I believe all the foils are one design. But
Yes. Thank you.
Terrific. So what's you show these double surface sails. How prevalent are those, and what's the performance advantage that you're seeing already?
Well, they outside of that prototype I show you, they don't exist yet. All right, so this is in prototype phase. It's being developed for the cup. The idea is as old as the hills. It's literally since the 1800s. A lot of people have thought of this idea, but it isn't even experimented with that much in the modern world because most of the rules have outlawed. The racing rules have outlawed those type of sails. So it's kind of return to the future in a way, but. They've modeled it in the software, and they think it's better enough for the cup and for making these boats foil that they're running with it.
Yes, John.
What is North doing these days about sails for small boats like a Starboat or an IC?
So another good question. Obviously, we still make woven Dacron sails for those type of boats and for one design boats. So there's a lot of class rules that specify sails must be woven, particularly woven polyester or woven Dacron. However, I will say that in 4 weeks' time, I've got a meeting with the new technical directors at World Sailing in London, and they seem to be keen to modernize and potentially open up those rules away from specifically using the term woven so that these boats might be able to use this Dacron product that we're talking about. Certainly that's our goal. It's in the rule maker's hands, but they're willing to talk about it. And for all the reasons I said, I think it will be a big deal because the sails will stretch less and they're going to last just as long. So.
Not counting the new ability to control the top of the, square top mainsails, how long is it going to be? Isn't a square top mainsail just more efficient because it falls off and depowers in any kind of breeze?
Correct. It twists.
And so how long is it going to take before we see square top sails in broad use? Do you have any sort of approximation? What do you think about that?
Well, I would... Maybe not obvious from where we sit here, but I would argue they are in broad use now. There's no new racing boat built that doesn't have a square top mainsail on it. I showed you a picture of the super yacht I race on. There won't be any performance super yachts built that don't have that anymore. There are no multi-hulls anywhere, even if they're cruising, that don't have square top sails. So as one of our salesmen just told me this week, because we don't offer every product we make in a square top configuration, one of our salesmen said, "Bill, square tops are mainstream now." So.
That answers the question. Bruce Monroe.
So, Bill, great talk.
Thank you.
When I started sailing, we had Egyptian cotton sails on our boat.
Oh, right on.
I bought my first Dacron sail from a guy named Kenny Watts in Southern California, about 1952, 53, thereabouts.
Yeah, probably one of the earlier ones. Yeah.
And then I bought my first North sail from a guy named Tom Blackaller over in Alameda, who was selling North sails at that time. And just a few weeks ago, I put my order in for a brand new 3DI sail.
All right.
And after your talk, I'm very excited about seeing what that will look like. And to answer Ron's question, if anybody wants to know what they sell for a 40-foot boat, I can answer that.
Well, wait, tell us now, Bruce.
Well, is that with or without the boat show discount?
With the boat show discount, what's the price?
Oh, about $12K.
$12K for a 44?
40 foot.
40 foot.
Yeah.
Great, Bruce. Thanks. Princess
okay.
looks very beautiful, too.
And I'll give you a report after I get my sale from super salesman Pete McCormick here.
Excellent. Wow, a guy who started with Egyptian cotton.
I remember linen sales. As a Sea Scout, we raised money painting Address on Curbs to buy the first Dacron sails in '57. And we were the first Sea Scout ship with Dacron sails. Amazing. We thought that was such a technical advantage. So what percent of all the sails that you make are made with materials that North makes versus materials made by someone other than North?
For upwind sails, so we're gonna have to break it down. So for upwind sails, the vast majority are made with materials we produce ourselves. So obviously all these composite sails, we're making those tapes and the building blocks. Even for a lot of upwind sails, we still produce our own dacrons, our own woven dacrons, and if we make a laminate, we produce that ourselves. What we don't produce ourselves in volume is high-end nylons for Spinnakers. So we're not a company with the not invented here or not built here mentality. If someone does something better than we do, we purchase it from them, and after many years of trying, we've decided for really high-end nylons that it's very specialized. So a lot of high-end Spinnaker materials tend to be supplied. We tend to buy in the general marketplace from companies like Contender. Although we make club race sort of nylons and cruising nylons.
So what's
because you make a lot of Spinnakers, on a unit by unit basis, it's maybe 60%, 70% our own materials. But on let's say on a dollar volume basis, it's probably 85% our own materials.
Of your own materials.
Yeah.
What's the future of symmetrical Spinnakers? Where are we going to continue to see those?
You're gonna continue to see symmetrical Spinnakers on displacement boats that have a defined hull speed. All right, and there's exceptions to every rule, but if the boat doesn't plane, to use an asymmetric, we call them apparent wind speed boats. Okay, so use an asymmetric well and efficiently. The boat needs to really sail faster than the wind speed or close to the wind speed. You sail higher angles, and this is when an asymmetrical sail is particularly good. But for hull speed boats that, it's better to point them as far downwind as you can, if not directly at the mark, and symmetrical Spinnakers are still the weapon of choice. I sail international 110s out in Inverness, and there's a couple of us that just insist on using an asymmetrical. But in a lot of conditions, the guys with symmetricals would just sail past a traditional boat.
So what excites you about your gig?
I'm a development guy, and you can probably tell by listening to me, I kind of get excited by materials and structural engineering. So, I've had the luxury of having a job for 22 plus years where I got paid for learning things. And so that's my thing.
And you brought 3 materials up. Last question. Talk a little bit about the materials that you brought up.
Yeah, so what I thought I would just say to help out my buddy Pete McCormick here is that, that's a piece of a 3DL sail. So, it was once a one-piece membrane, and that's what now is widely referred to as a string sail, okay, because you can see all the strings in it. And everybody else, besides North Sails, because 3DI is a patented technology, obviously, it's new. It's basically producing a sail like that. But what they're doing is they're covering it with a material of the 3DI color. And so they're producing sails that look like that, and it's just kind of a cover over the top of that string sail. So it kind of looks like our sail. And so that's a bold-faced promotion.
Thank you. We have one more question. Microphone, Charlie, over to Bill Halberstadt. Thank you, Bill.
Thanks. I'm intrigued by what you were saying about the longevity of the 3DI sails, and I wanted to know whether I could expect 50,000 miles out of my 2013 3DI sails. Asked differently is, aside from total failure, where they just split, how do you know when it's time to retire your 3DI racing sails and get new ones? Now, I don't want to ask Pete that. He'll want to sell it. I want to know from the technology.
Well, you know, it's time when you feel the time is. Again, I kind of spoke about this earlier, but everybody who's racing has a kind of a different level of tolerance, you know? So, you know, at the Grand Prix end of the sport, where they have a lot of money to spend, their tolerance for less than absolutely optimum shape is very low, right? And, you know, but for most of us, I think our tolerance for less than optimum shape is very much tempered by how much money we want to spend. So, you know, the time to buy a new sail is when you no longer think the shape is optimum. You can do that by eye, probably, if you've been sailing for a long time. Probably the guys that are trimming your sails would be more than happy to tell you what they think about that. Or, you know, if you sail on a one design boat, you'll probably notice that you're not as fast through the fleet as you used to be. And, you know, more than likely that could be that it's time for sails with a newer aerodynamic shape. I'm sorry if that sounds like an invasion, but, you know, it's really when you think the shape is not optimum for what you're trying to achieve anymore. You know? And, you know, it's just a fact of life, and this is why Grand Prix people and America's Cup people buy so much sails. The new sail's just always the faster sail because it's still at the shape it was designed to be at to propel the boat forward with the maximum efficiency.
Thank you very much, Bill. Thanks for attending the Wednesday Yachting Luncheon.
Thank you, Ron.
Our guest today, Bill Pearson, is the technical director for North Sails, the largest sail maker in the world. And with that, the luncheon is adjourned. Here, Bill. Get on your knee.